Good afternoon, everybody. Thank you for joining us on another webinar by Lachisoft. My name is Nick Zulfikar. I'm the Director of Client Services here. With me is my colleague Ron Hussain, who's our Senior Technology Evangelist. He's going to be covering a very exciting topic today, how to scale your ASP.NET Core applications using NCache. As you know, ASP.NET Core is an open source cross-platform framework used for developing web applications. The beauty of these applications are that they could be used and deployed in any operating system, Mac, Linux, Windows, etc. Typically, they're very lightweight and fast, but as Ron is going to take us through, they do have some scalability issues, and he will give details on how to go over these scalability issues and by using distributed cache like NCache. He's going to talk about caching sessions and objects in memory and to take care of these performance and scalability issues that are posed by these ASP.NET Core web applications. With that, I will have Ron take us through the technical presentation. If you have any questions, you can always type them in the questions box in the GoToWebinar, and I'll be able to ask those from Ron. So Ron, kindly get started with your presentation, please.
Thank you very much, Nick. Hi, everybody. My name is Ron, and I will be your presenter for today's webinar as far as all the technical details are concerned. So, as Nick suggested, today's topic is scaling ASP.NET Core web applications with NCache. So we'll extensively talk about ASP.NET Core framework, how you can actually use NCache and help resolve all the performance and scalability related challenges that you can face within an ASP.NET Core web applications. And as part of this, I'll show you some hands-on examples of different caching features, different options that you can utilize and get started with distributed caching utilization inside your applications. Let's quickly get started. Since we have a lot to cover, so I'll quickly go through some of the introductory slides so that we build some basic concepts on what are the challenges, what are the issues that you would typically see within an ASP.NET Core web application. All right, so first of all, what exactly is a concept of scalability? What is scalability? Scalability is high application performance under peak loads. Typically, when you design an application, you're performing certain tasks, right? So you consider latency into the factor. So performance needs to be super fast. Usually under low load, let's say 5, 10 users or 50 users or 100 users, performance is not really a problem, right? So you always have your applications performing in a pretty fast manner under low user load. But when it comes to handling peak loads, when your application load grows, typically systems tend to choke down. So if you can manage the same kind of performance that you had with 5 users or 10 users, and if you simply grow that capacity to, let's say, 1,000 users, 5,000 users, or even 50,000 users and more, if under peak loads of such nature, you can achieve the same kind of performance out of your system, I would categorize that ability as a very scalable system. So that system is very scalable, where it can exhibit high performance, low latency under high throughput. So if you have more and more request load and latency is something which is not increasing by any factor under that peak load, that system is qualified as a very scalable system. That is a very important concept. Typically databases and other data sources do not have that ability. They choke down under peak loads, and we'll discuss this in coming slides. Typically within an ASP.NET Core web application, when you create a web form, if you have a web garden, you utilize the resources of your web servers in a very effective manner by distributing the load on multiple worker processes, creating a web garden. Then you can also create a web form where you can deploy multiple servers, and you can increase the capacity of how many requests you can handle out of that system. So as you add number of servers, the request transactional capacity actually increases, and it's increasing the reads per second and writes per second as well. And this could also be based on the user load. Let's say 50,000 users, you're not able to handle more transactional load out of the system. And even though you can add more servers, and here's a non-linear system, after some number of servers, and when your transaction capacity needs to increase and you're putting more and more load, system actually chokes down. It plateaus at at some point, and then actually it degrades because system is overwhelmed with the amount of requests that you're planning to handle, and new request load is coming in at a rate greater than the rate that your application is able to manage that. So it's a typical example of a non-linear scalable system. Within an ASP.NET Core framework, typically we'll talk about web applications and web services. ASP.NET Core web apps are getting very popular because of being cross-platform. You can deploy these on Windows, you can deploy these on Linux and other operating systems as well. It's lightweight. You don't have to deal with the entire package. It's modular, so you can just use the module that you need and actually take advantage of it. It is getting very popular, so it needs scalability requirements fulfilled as well. So platform itself is scalable, as we've discussed that you can put a load balancer in front, but there are scalability issues with data sources, which I'll cover next. ASP.NET Core Web Services is another kind of application, web application that may need scalability requirements out of it. Then an associated concept, you may have a backend, right? Typically a web application talks to backend, and it could be a microservice, it could be a workflow, it could be any other .NET or .NET Core application. So that application may be dealing with backend data sources, so it makes more sense to use scalability measures into that application architecture as well, because that's the one which is dealing with some data sources which can become source of contention. So in general, we'll focus on ASP.NET Core web applications today, but in general, you can utilize this concept, the concept of caching and achieving scalability in any ASP.NET or .NET Core or typical ASP.NET or ASP.NET web applications. Where exactly is the problem? We discussed that system itself is very scalable. ASP.NET Core framework allows you to create a web form. You can also have a web garden scenario. Scalability problem lies with backend data storage. Your application tier scales out nicely. You can put more and more web servers, but all of these web servers, app servers, they need to interact with some kind of backend data source. It could be your relational database, it could be a non-relational database, it could be file system, it could be any legacy data source for that matter. And it's very good for storage purposes that these data sources are, but when it comes to handle extreme transactional processing, they tend to choke down. They slow things down, and then they can choke down completely as well. And it's something that you wouldn't want to afford, specifically if your data is of sensitive nature, your users are making some requests. It's an e-commerce platform where a user is about to make a payment, but due to bad performance, bad user experience, users are not able to actually complete their transactions. NoSQL, we have a product called NOSDB, which actually helps resolve some of the scalability issues with relational data sources and others, where you can use that as a document store, as a data store. But they require that you replace your existing relational databases, right? So it's not a usage of NoSQL and relational data source side by side. It has to be architectured around NoSQL. So you may need to change your applications to great extent in order to start using NoSQL. So that's usually not an answer to help serve. Solution is very simple, that you have excuse me, you use a distributed caching system like NCache, and you use it in between your application and your backend data sources. You create a cache cluster, and how it's very scalable. First of all, it's in memory, so latency, it's super fast in comparison to your backend data sources, right? Any disk-based storage, any relational data sources, or even NoSQL data sources, a distributed caching system like NCache is super fast because it's in memory. Secondly, you can add more and more caching servers. You can start up with 2 servers in the cache tier dedicated, and then you can add more servers on the fly, and you can actually improve the request handling capacity out of the system. So more servers mean more request handling capacity, and without slowing performance as well. So latency stays same or it gets improved, and then more and more throughput can be achieved out of the system as you add number of servers. So if you were handling 50,000 requests with 1 server, you add another server, you increase that, you almost double it. You add third server, you triple it. So simply adding more servers linearly improves performance and scalability out of the system. And then there are a lot of features, very easy ways to plug in a distributed caching system like NCache into your ASP.NET or .NET Core application. As far as deployment architecture is concerned, NCache can be deployed on Windows using .NET and .NET Core framework. So that's preferred platform typically. Then it can also be stored, actually installed on Linux environment as well, because we have .NET Core Server fully supported available on our website. So if you want to install and use NCache on Linux servers, it's very flexible and it's fully supported on that end as well. On the client end, excuse me, it could be used by ASP.NET Core web apps. Again, on Windows or Linux environment, we have fully functional client for both .NET Core web services or .NET Core, any other .NET Core general backend or any other services that may be being used in your environment. So client of .NET Core is fully supported, natively available, written in .NET Core and available for .NET Core on Windows as well as on Linux, and similarly server portion is also available on Windows and Linux environments. It's also supported on Windows Nano as well. Only prereq for .NET Core is 2.1. For .NET Framework, it's I think 4.7. So I wanted to cover that. Next, I'll talk about how to actually get started and start using NCache in ASP.NET Core web application. First and most important use case is application data caching. Now, typically we discuss that data sources are slow and you don't want to go, to data sources again and again. And specifically for data which is of reference nature, it's more reads than writes. So you're reading that data a lot of times than you're writing, right? So it would not make sense to go back to the data sources. So you might want to cache data inside your application, through your application. I wouldn't say inside your application, as much as possible. And this data caching features within NCache are pretty elaborate. You can use IDistributedCache interface, which is the standard for ASP.NET and .NET Core side of things, where it's a standard for caching, where you can plug in any provider. NCache can be a provider for that. So whatever features that you're using in IDistributedCache, you can use NCache as a source for those features. NCache can be the caching product for that. And then you can make use of Direct NCache APIs inside your application as well. This is more elaborate. A lot of, IDistributedCache is more standard approach, where you can plug in any provider, including NCache. Whereas NCache API gives you a more personalized, more advanced view of the caching. It has a lot more features that you would normally find in IDistributedCache. With data caching, you can cache almost everything. It could be your domain objects, collections, data sets, images, any sort of application-related data that you want to cache, and by doing that, you want to save your backend database trips. You should plan on using the data caching for that. Second feature around this is ASP.NET Core specific caching, right? So there are three main features right here. We have ASP.NET Core session storage, again through IDistributedCache. NCache can be provider, and NCache also gives an official provider, session store provider of its own as well that you can use. So session caching can be completely made available inside NCache, and this would give you lots and lots of benefits. It would improve your performance in comparison to data sources or in comparison to in-proc or state service. NCache is a lot more scalable. It's not a single point of failure, and it's pretty elaborate in terms of the feature set that it offers for session state caching. ASP.NET Response Caching, that's a new term for ASP.NET Core side of things. Previously we had ASP.NET Output Caching. So NCache has a provider for ASP.NET Core Response Caching as well. So if you're using ASP.NET Core Response Caching, or if you're planning to use, NCache should be the preferred choice, because it's distributed in nature in comparison. It's not sending any outputs back to the browser. It's stored on the server side in a distributed manner, and there are lots of features where you can refresh outputs after some time. So page responses can be cached for static content within your ASP.NET Core web application. And then if you're using SignalR, that's a specific use case. If you're using ASP.NET Core SignalR within an ASP.NET Core web application, you can plug in NCache as a Backplane. There could be a real-time application which needs to push some functionality onto the clients and doesn't want to wait for clients to send updated requests. NCache can be used as a backplane within the web form. So Backplane is a must for web forms if you're using SignalR. So NCache can act as a backplane and can utilize the messaging platform of NCache. So that's the third feature around here. So for ASP.NET Core specific caching, you have options of using session state. You can use response caching, and you can also use SignalR Backplane. And these are, just startup.cs changes. You don't need to make any huge application code changes. Existing applications can actually plug in NCache as providers for all of these. And I'll actually show you the detailed examples for all of these once we progress into that portion. Third important use case of a distributed cache in ASP.NET Core. It's not directly in ASP.NET Core, but this is relevant, so I wanted to highlight this. Typically, you wouldn't want to have any kind of messaging within an ASP.NET Core. You may have that requirement, so for that you can use the pub-sub messaging. But typically, based on our experience, ASP.NET web applications may not need to coordinate among other ASP.NET instances deployed on different servers. HTTP, ASP.NET or HTTP requests are stateless in nature, so you might want to keep that in mind. You don't need to coordinate between different requests on different web servers. But typically, your ASP.NET Core web application may be talking to a backend, a middleware, right, which is in turn talking to some backend data sources. So that middleware could be a microservices written in .NET or .NET Core. That may need to have app coordination between different instances. Since microservices architecture demands that these are loosely coupled independent modules within application. So if you need to have some kind of data sharing or app coordination, you might want to use messaging platform out of NCache. Since NCache is a centralized store, it can act as a pub-sub messaging where you can have different topics, and those topics can be subscribed, and publishers can publish message to those topics, and subscribers can use those messages. So you can interact between different applications using our pub-sub messaging platform. So these are 3 different use cases, 3 different categories. I'll give you some code examples in upcoming slides. For now, I'll actually get started with ASP.NET Core specific caching, and then we'll focus on app data caching and then pub-sub messaging. Please let me know if there are any questions so far. Next, I'll actually show you next I'll actually give you a quick demo of the product. So I'll show you things in action. I prepared 2 sets of servers. I have a Linux environment, and then I also have a Windows environment, right? So we'll get started with Windows environments. I'll show you all the configurations that need to be done, and then we'll progress into, we'll move into the Linux environment and take it from there. All right, so for Linux side of things, Windows side of things, let me just remove this. I'm not going to register it. All right, so from a management standpoint, what you really need to do is download our product from our website, and for that you can just go to a LachiSoft download page, install it on Windows or Linux environment as needed. If you're interested in on Windows, you can just download the Windows edition. If you're interested in Linux, you can use the .NET Core Linux installation. This is through tar.gz or through Docker, right? So both options are available. You just need to make sure that from Windows standpoint, you have .NET 4.7.2 available, and from Linux standpoint, you need .NET Core 2.1. And if you're using .NET Core on Windows, you need .NET Core 2.1 on Windows environment as well. All right, so I've already done this for Windows as well as for Linux. Installation is something that we've already done. So I'll quickly help you get started with cache creation. We have option of using PowerShell tools or GUI tools. On Windows, I'll use GUI, whereas on Linux environment, I'll use the PowerShell tools. I'll just create a named cache. All caches need to be named. Let me just name this, let's say Windows, right? So that's my Windows cache. I'm going to just append win at the end. So demo cache is the name of the cache. I'll keep everything simple. Partition replica cache topology with async replication. We typically do our architectural webinars where we talk about NCache. In general, we talk about NCache, features, and we extensively cover these details where we show all the configurations in great detail. So in this webinar, I'm just going to focus on the client side of things. So I'm just going to skim through all of these. So demo 1 and demo 2 are going to be 2 servers which are going to host my cache. So the NCache is already installed on these 2 servers. TCP/IP NCache is driven through TCP/IP port, so I'm going to pick that. Size of the cache, I'll choose 1 gig per server. And then evictions, let's turn off because it's ASP.NET specific caching session data, so I don't want my cache to be evicting anything when it becomes full. So for object caching, you can create another cache which actually evicts data when it becomes full, so that it makes room for the new data. I'll start this cache on service startup, so each time server gets rebooted or service gets recycled and cache was stopped, it would just restart the cache, start the cache in that sense. So that's it, my cache has been created on these 2 servers. I'll add my box as a client. And this will just add my box as a client, and that's it. I'll just right click and choose start, and this will start the cache on my box. All right, so this will take some time, and as soon as this starts up, I'll actually show you and test this real quick. As a matter of fact, I'm going to show you a Linux set of servers as well, and same environment is going to be made available on the Linux as well. If I right click and choose statistics, this opens up a performance counter window, and next what I can do is I can so let me just break this. All right. All right. So my cache has been configured, and I'm actually looking for a stress testing tool application which comes installed in the PowerShell. If on the Windows, if you need to manage anything from NCache standpoint, you can simply use the PowerShell commandlets. Actually, it's using the demo cache win. So let me just. All right, so I've ran the test stress application which comes installed, and momentarily, actually after some time, it would just generate some dummy load on my cache cluster. You can see about 500 to 600 requests per second on each server. So if I just run the same command from here as well, and there are command line tools available as well. So if you guys need to do that, actually I don't have that. Let me just copy it one more time. All right, let me just type it for you. And demo cache win. It takes a cache name as an argument. I thought that was a default one. As a matter of fact, let me just open command prompt and run the command directly from there. All right, so I'm going to simulate some more load using command line from this. I think the PowerShell version on demo environments is not compatible to what I'm using, so I'm able to run it from my box. So let me actually show you this through command lines. Right here, I have set up all the command line tools that are needed, and I can use the same tool from here as well. And this will just increase the load on my server from 400 to 500 to 1000 requests per second. I can right click and choose monitor cluster, and this would open the monitoring tool which also comes installed with NCache, and you can see all sort of activity being generated here as well. Now if I have to bring you to the Linux side of the servers, so you can create cache on Windows. I've demonstrated that here for ASP.NET and ASP.NET Core applications, and similarly you can create this cache on Linux environment as well. And for Linux, I have an environment already set up. I am inside NCache bin directory where we have NCache PS. What I've done here is I've imported a module, so I've ran the command of importing NCache PowerShell module right here, and by doing this I am actually able to run all sort of different commands to review my cache scenarios. So I would first of all show you all the caches that I have configured. So for that I'll run get caches, give this server 115 and 116 are going to be my NCache servers on Linux. If you notice, 107 and 108 are the servers on my Windows environment, and similarly I have a 117 box as a client and 101 box on Windows, on Linux and Windows respectively. So I'll show you the list caches. You can see I've created a demo cache. It's on 115. It's also created on 116. It's stopped on both servers. So right, so it's currently stopped on both servers. So what I'll really do is I'll start the cache on each server one by one. Right, so I can just say start cache on 115. All right, I'll get caches information with detail so that I see. You can see demo cache is now started with 115. 7802 is the active partition and 7803 is the backup partition. It shows the uptime and count as well. I need to now start this for 116 as well. Start cache is the PowerShell commandlet for that. And once it does, it will automatically join the cache cluster. The cache creation part can be done through create cache. There is a new cache, and then there is an add node functionality which you can actually use. I'm sorry. So we have get caches again. If I get the statistics from one of the boxes, it's now showing 2 servers. And if I run this from 116, it should show the same view from there as well. All right, so we have cache running now. Next thing I'll do is I'll actually show you, since I'm running this from 117 box, this is one of the Linux boxes, I will run the stress test to simulate some dummy load on my Linux box as well. And for that, you can also monitor Linux servers directly from your NCache manager by just specifying the IP address of the Linux boxes. And this is because Linux does not have .NET Core on Linux does not have performance counters as yet, right? So they have to rely on Windows box in order to manage and monitor stuff. So you can see these are 115 and 116 environments. So I've shown you 2 different environments. You can simulate, you can create a cache on Windows, or you can create a cache on Linux, and then you can run applications on Windows cluster, and run applications on Linux cluster as well. So it's completely flexible because everything is driven by .NET Core. You can have .NET Core installation on Windows server side and .NET Core installation on Linux server side, and same goes for client side details as well. So that was a quick demo of the server side things. Next, I'll show you the ASP.NET Core sessions. For that, we have 2 options when it comes to NCache.
Ron, I have a question here. Are there any limitations of NCache on .NET Core Linux?
Okay, so NCache on .NET Core using Windows environment, and it's fully supported as far as feature sets are concerned, right? So there are no feature level differences. Only difference is .NET Core itself is not mature enough in such a way that it's not giving performance on Linux. So as far as performance monitoring support is concerned for NCache, it's more mature on Windows side of things in comparison to Linux, but as far as features are concerned, they are exactly the same. So no limitation from our side. It's just the platform which is evolving at this point.
Okay, thank you.
Very good. All right, so for ASP.NET Core session storage, we have 2 options. That's how you can plug in NCache. Typically, you use IDistributedCache for session storage. That's the default option in ASP.NET Core web apps. It comes with in-memory provider, which means everything runs inside the process memory. That works, but essentially it gives you single point of failure issues. If the worker process recycles, you lose everything. Then you may have to have sticky session load balancing because you have to point to the same worker process in order to get the session out of it, and it's not scalable. Similarly, SQL Server is again a single point of failure, single server, not scalable, and it's very slow as well. And then you can use providers like NCache, where you can plug in NCache for IDistributedCache. And then I'll also talk about NCache sessions provider. That's another way you can use NCache for session management. So let's quickly get started with IDistributedCache. I have a sample application which is right here. All you have to do is, for IDistributedCache, it's pretty straightforward. Inside your startup.cs file, first of all, you need to add the NuGet package of NCache. If you go inside the music store, you need to have the NuGet packages, and for that you need alachisaw.ncache.session-services. So 4.9 is the NuGet package that I've introduced into this application, and that's all what you need for .NET Core ASP.NET Core application to start using the session state for IDistributedCache. And next, inside startup.cs, you need to plug in NCache as a provider. Here is the code for it. There is services.add NCache distributed cache. If I take you inside this method, right, so there is NCache session extension class. So NCache has extended this functionality, and it has given a bunch of methods where you can actually read configurations inline, right? And then you have add NCache distributed cache section, which is reading configurations, and inside the application you just need to call use NCache sessions. That's it. So this is only two set of commands that you run: read session and read configurations, and then call use sessions. And configuration reading part can be done in two different ways. One is that you provide inline details. For example, we just created a cache named demo cache on Linux environment, or let's say on Windows environment, this or that, and we are providing that as a source for all the caching for session state. So that's one way of specifying configurations, by calling add NCache. Actually, this is not the correct one. This is right here. Add NCache distributed cache. So you can specify the name of the cache right here. Let me just comment this one out. All right. And the other option is that you don't use inline configurations. You actually specify configurations inside a configuration file, a JSON file in the app settings. So you can use the same set NCache session configurations, and you read the section from here, and all the configurations are specified from here. So either way, through config.json or through inline configurations, you need to set this up. And once you've done this, if you're reading the configurations through a JSON, you need to call add NCache distributed cache method, as you were calling right here. This is taking configuration. This is not taking any configuration. It already has configuration. And then you call use sessions. Now, benefits of NCache as your IDistributedCache provider. I've mentioned that NCache can act as a provider. So we already covered why it's better than inproc, why is it better than SQL Server, and other options. But when you plug in NCache, first of all, it's pretty straightforward. NCache as a provider. Secondly, NCache has a lot of server-side features that you can utilize in comparison to other providers. For example, you can remove any server node without stopping your application. You can add more servers on the fly. You can set up encryption. You can set up security. You can set up alerts on the caching. You can set up some cache level events where cache becomes full and you get notified. There are a lot of management features from the cache standpoint. And since it's a standard, you can just plug in NCache real quick and test it and see things yourself. And it's already going to give you performance improvements, scalability improvements, and reliability into your picture, into the architecture by just plugging in NCache at IDistributedCache. So if you guys are using IDistributedCache and using some session provider, I would highly recommend that you use NCache and see things in action. Second option of using session state, for those of you who are not happy with the IDistributedCache functionality because it's limited, it's standard but it's limited, they can actually opt for NCache sessions or provider. Complete provider offered by NCache. NCache manages everything. It gets plugged in as a provider, and it has a lot more features. And those of you who are actually developing the application and planning to use session state in ASP.NET Core, they should consider NCache sessions or provider directly. Let me show you how this works. So it's very simple. Same sample application. I'll just comment out this section right here. Again, it also has two options to set up. The name of the method is add NCache session. It's different from add NCache distributed cache, which is for IDistributedCache. Actual provider of NCache, official provider, comes with add NCache session. Again, you would just specify the name of the cache, and then you would call use NCache session towards the end. Right? You just plug in and it gets started. Difference between IDistributedCache and NCache. Let me just quickly show you some of the differences. I think a help document would help me here. All right. First of all, NCache has a lot more features in terms of IDistributedCache versus NCache provider. You can use multi-site sessions with NCache. If there are two active deployments, geographically separated applications, two different applications, and they want to route traffic from one region to another, you can use our multi-site session for that. There could be a maintenance on one region that you need to map onto the other, and vice versa. So you might want to use this feature here as well. Then session locking on the client side is another feature that NCache provider has, where IDistributedCache is not that mature on that end. Although NCache has integration for it, but NCache IDistributedCache integration is limited because of that, whereas provider itself, NCache official provider, is a lot more elaborate. You can have event logging, you can have client-side logging, server-side logging, API logs, client-side timeouts that you can specify. So all the good stuff that you normally don't have in IDistributedCache, you can get that by using NCache as your session support provider for that matter. I hope this helps. So that's the first way of using NCache in our application caching. Next, I'll show you the response caching. Now, response caching is again very simple with NCache. For static content within the application, it makes more sense to enable response caching. ASP.NET Core gives you 3 options here as well. You can use HTTP based caching, which sends page outputs onto the browser. It works, but it can lead to stale data because data is not changing on the browser until you actually refresh it. So server data can change. There could be a database update, and that could completely trigger an invalidation, but browser would still have the older copy, so it's not suitable in that way. Then you have an in-memory caching option in ASP.NET Core, which works, but again, it's a single point of failure. It's their own provider, and it has performance and scalability issues. The most suitable option is again through IDistributedCache and cache provider, because NCache is distributed in nature. It's super fast. It has features which allow you to refresh, set up some expirations, some timeouts, and you can change the output based on the content which is changing. So you can use NCache as a provider for that. And I have a sample application. All you have to do is set NCache for IDistributedCache, add NCache DistributeCache, and although you're using IDistributedCache sessions or object caching or not, but you can still use add response caching extension method. If I quickly take you inside this. All right, I think I'm running this, so inside extensions. So that's the method that we have. If I run this application real quick, it's using one of my local caches, and I want to quickly run this and show you how this works. Let me just clear the contents. So any static content, you don't have to execute that page anymore. You don't have to go back to the data sources. Everything would be cached in NCache in a distributed manner, unlike in proc or going back to the browser. So HTTP option and in proc option are not comparable with what NCache offers. And don't forget all the server-side features that NCache exhibits. You can add servers, you can remove servers, you can increase capacity, you can get more scalability, extended logging. So all those features are going to be made available as part of this. Right, so I go here. All right, so it has cached an item with expiration, and it has a vary by tag. So you can set up headers on the pages. So I've set up the response caching header on about page, the view, and there are two items in the cache as we speak. So let me just refresh this page real quick, and you would see, I think the item count should be 3. One item got expired, so it would expire after some time as well. So that's how simple it is to use session state through IDistributedCache through provider, and similarly response caching through IDistributedCache as a middleware. Please let me know if there are any questions at this point. Otherwise, I'm going to move on to SignalR Backplane.
I have a question. Are there any feature level differences between ASP.NET and ASP.NET Core session features within cache?
All right, this question is in regards to our ASP.NET provider versus ASP.NET Core provider, right? So there are no feature differences. NCache provider, if you're comparing NCache ASP.NET provider versus IDistributedCache, we already covered that, right? But for ASP.NET NCache session state provider and ASP.NET Core session state provider, feature set is exactly the same. What we have been historically offering in ASP.NET side of things, it's available on ASP.NET Core as well.
Okay, thank you.
Very good. Third important use case in this section, as we discussed at startup, was the SignalR backplane. After that, I'll talk about object caching, and we'll spend quite a lot of time over there as well. So SignalR backplane is something that you need as a must if you're using a SignalR application, right? So and for that, I'll just open a sample of SignalR chat. So NCache can be plugged in SignalR as a backplane, and any functionality that you need to push back and forth between your client browsers through JavaScript on client end or on the server end, you can invoke those messages to all your end clients through WebSockets using SignalR, and NCache can act as a backplane for it. In comparison to SQL Server or Message Bus, NCache is a lot more faster. It's a lot more scalable. So this is a sample application which is available, and you can find plenty of documentation on our website around it as well. If I search for SignalR inside the documentation, I should be able to go to NCache. Right, so this talks about the extension. So all you need to do is set up a configuration section, include our NuGet package, and then attach NCache as a SignalR backplane, and that's it. And here is a sample application that is doing exactly that. All right, so next I'll talk about the object caching use case. Again, we have two options here for NCache, and I'll cover all the object caching features in great details here, because that's the main focus that I want to cover. What we've covered so far is something which is pretty plug and play, and for data caching it's pretty plug and play if you're using IDistributed but for object caching and entry framework core cache, you have a lot of features that you can get started with. Now for data caching, anything which belongs in a database, it makes sense to cache it, and for that you can get started with IDistributed-Cache. If you're already using IDistributed-Cache in proc option or any other provider for that, you can plug in NCache, and you remain within IDistributed-Cache field because those are the features that you're using. NCache would give you all those features fully supported, but NCache as your provider for that. And here is a feature set. If I show you the sample application once again, inside my music store, I have controllers. I think it's the store controller. So this store controller, what it's really doing is, and I'll actually show you how to handle serialization as well. I've commented this section out, and I need to, this needs to be commented. All right. So this is our IDistribute, and let me first of all show you the IDistributed-Cache interface. So these are the methods, and you can use async invocation, refresh async, remove async, and set async. So this is what Microsoft offers as IDistributed-Cache, and if you use NCache as a provider for it, you get to use all these features. Now these are very limited feature, but this is a standard way of doing things. Nice thing about IDistributed-Cache is that you can plug in any caching product. You can plug in NCache, you can plug in Redis, you can plug in provider for that matter, and this would just work out of the box, where providers can be changed and your application code doesn't have to go changed for that matter. But again, this is limited. One limitation that I can tell you right away is the feature set. It's not pretty elaborate. You get to have only these features, and then byte arrays, you have to manage serialization and deserialization yourself. But since NCache has an integration for it, all you have to do is plug in NCache on IDistributed-Cache in startup.cs, right? So we already covered that. Here is the section for it. You just plug in NCache as your IDistributed-Cache, and any command, any operation that you make are going to be handled by NCache. What we have really done here within this sample application is we have given you extension methods to manage serialization as well. So that's a plus. When you use NCache for IDistributed-Cache, you don't manage serialization yourself. And I'll give you a quick example of it. You can see one of the methods is try get value. So if I show you here, the IDistributed-Cache interface expects a byte array when you get an item, and it asks you to add an item with a byte array. It doesn't give you the object format, whereas our store controller, this method right here, is calling cache try get value, and the value part is actually an object, right? If I go inside this is an extension method implemented by us in this sample application, where it is taking care of the serialization and deserialization as well. So this is something that you have to do, but you can use this as a reference when you use IDistributedCache. Here's another example of this set object. So if I have to set an object using IDistributedCache, I can first of all serialize it, and then after serialization I can actually call cache.set, which is the IDistributedCache method for that. So this is how you would plug in NCache. You just need to plug in NCache as IDistributedCache, and whatever support IDistributedCache is offering you can use, and plus more you can use serialization with NCache. Second option is through Entity Framework Core Cache. I would just spend 1 or 2 minutes. There is a separate webinar that I've done on this one as well. So if you're using Entity Framework Core inside your applications, there is a option of plugging in NCache and using NCache for Entity Framework Core. There are extension methods that we've implemented, and I'll just quickly show you some of the examples of those Entity Framework extension methods. So NCache can act as a provider for reference data and for transactional data. There are different features that we have given. So we give you caching options, right? And based on that, your link queries can have from cache, so that it reads only from cache, not from the database. That's another one. Then we have load into cache, load all the data that you retrieve from the database through a link query into NCache automatically using these extension methods. And then there is from cache only, I guess, which doesn't go to the data source, it only reads from the cache. And it talks about different approaches. There is a separate webinar that we've covered on this one as well. So that's another way of using object caching through Entity Framework Core if you're interested in saving database trips. Now, third important aspect that I want to cover in great details is the Direct NCache API support. NCache allows you to call APIs directly in ASP.NET Core application, and that's the most elaborate way of using caching, because it gives you a lot more flexibility on what you need to use. First of all, feature set is huge. You can use create, read, update, delete. You can have tags, you can have locks, async invocation of these, object query language, link integration, server-side code, expirations, database dependencies, read through, write through. So all the good stuff is available inside NCache Direct API calls, and it's very easy to get started with this. Same method I'll actually show you, since I have this details controller right here, and I would just show you this one, which is using Direct API calls. All you have to do is add NCache NuGet package, right? The SDK package, and then you need to include this namespace right here. And after that, you can simply call cache methods. And let me show you these features in comparison, right? So there's our cache clause. Right, so you can see the list of adds, the overloads, add bulk, add dependency, aggregate, clear, delete, searching through SQL and through link, get bulk, and the list goes on. So that's the difference between IDistributedCache and NCache, where you're not limited by the feature set if you plan on using NCache directly. And API is pretty straightforward. You store everything in a key value. Value is a serialized object, which NCache serializes for you. Just pass object to NCache, and it allows you to add, update, delete items using the simple, pretty intuitive APIs inside your application. And as an example, I'll show you this one real quick. It's calling cache.get to get an item from the cache, and similarly it's calling cache.insert to insert an item from into the cache. And we have detailed list of applications, sample applications, which come installed with NCache for that matter. I'll talk about some of the object caching APIs, some of the highlights. Please let me know if there are any questions. Expiration, we have time-based expiration. When you plan on caching data, you may have a requirement of caching data for some time. So you can use absolute and sliding expiration. Absolute is a timeout that you specify ahead of time. Sliding is based on the usage pattern. For reference and transactional data, you can plan on using absolute and sliding expirations, and items would automatically be expired from cache. When you cache data, mostly reference data, you want to keep all your data in NCache, and that data also belongs in the database, so data exists in two different places. So database dependencies can ensure that you, as soon as database changes, you can remove or update the items in the cache automatically as well. So with the help of SQL dependency, you can achieve that use case effectively with NCache. This is also possible with non-relational data sources. File dependency and custom dependencies are designed just for that. And then we have key-based dependency, where you can handle one-to-one, one-to-many, and many-to-many relationships inside NCache. When you use cache, it's a key value store, right? So items are stored in object, whereas data sources have tables, relations, which have relationships with one another. So you can have the same kind of approach within NCache by using the key-based dependency and manage relationships between different objects. Logical groups, grouping and tagging can also be done. You can attach a keyword to the cache items, and you can create logical groups inside NCache as needed. I want to show you the link, extension of NCache, the link integration of NCache. You can run link queries directly on NCache. For example, you stored products, let's say thousands of products, but you're only interested in products where product ID is greater than 10, right? So you can run a link query directly on the cache. You can make product object iQueryable with NCache query, and this needs to be indexed with NCache, and then you run link queries, and NCache would work without any issues. It has support for link, where you can run link queries on NCache instead of on the database. Similarly, we have SQL-like searches, and for that I also want to show you a sample application. Again, you index the objects, and you can run an SQL-like search, and you can perform criteria. Select product, where this product name is HTC phone, right? Similarly, you can also, and that product has to be added in the cache, and criteria can be mapped. Product where ID is something, where product.id, product price is greater than 10 and product price is less than 100. So you can run SQL-like queries on NCache as well. So you already see some benefits in comparison. Read through, write through, those are server-side code, where you can put your data access layer with NCache, and NCache would call it on your behalf. And then we also have PubSub messaging. Again, it's not a direct use case in ASP.NET Core web applications, but it's still something that you might want to use. So we have complete publisher subscriber model. NCache can act as a communication platform where you can have different topics, and publishers and subscribers can publish and subscribe messages in that topic respectively. All right, I want to spend some more time towards the, I think, last 6-7 minutes around the architecture, and then we'll conclude it. Please let me know if there are any questions at this point. NCache is 100% peer-to-peer architectured. It's based on dynamic cache clustering protocol. You can add or remove servers on the fly. Unlike other products, it's highly available. It does not have any single point of failure. Cluster can readjust itself, heal itself if there are any changes on the cluster level. So maintenance is a lot easier. Server, going down is not going to impact the performance or application, uptime. It's going to be 100% uptime, a highly available cache scenario for your applications. It comes with partitioning. You have partitioning, and then you have partitioning with backups as well. So you have data partition, and each partition can have backup on another server. So essentially, there's a topology where you can have two partitions, an active data partition and a passive replica partition of another server. So if server goes down, you don't lose any data. Backup is automatically made available. It's built into the protocol. Load balancing and data distribution is also built into the protocol, and you can add as many servers as you need to. In this case, we have 3 servers with partitions and replicas. So one's active, backup on 2, server 2 is active, backup on 3, and server 3 is active, backup on 1. So there's no data loss if a server goes down. If server goes down, surviving node would automatically make the data available, seamless to end users, applications, and then it would heal itself and again formulate a 2-node active backup partitions without any data loss or application downtime. Client cache is another feature where you can keep data closer to your application in a synchronized manner. That's another topology for reference data use case, and it's keeping subset of the data so that you don't go to the client clustered cache, and this saves your network hops and improves performance. So any changes in client cache are propagated in the server cache and vice versa. NCache is managing the synchronization overhead as well. So it's very fast for reference data scenarios. It's a performance-centric feature out of NCache. WAN replication is available. You can have 2 different data centers and active passive. One-way communication, replication of one cache to the target cache, or it could be active-active where both caches are transferring data to one another. It's part of the same product, and it's different from multi-site sessions. It's for object caching. If your data needs to be on two different data centers, you can use this WAN replication feature of NCache. Towards the end, I'll give you a quick comparison of NCache versus Redis. First of all, main comparison is around .NET offering. NCache is natively available on .NET and .NET Core. It's written in .NET and primarily for .NET, and we've just recently released .NET Core server of NCache. And with the help of that, you can run NCache on Windows using .NET and .NET Core official support from our end. And similarly, you can run NCache on Linux environment as well using .NET Core Linux server of NCache. Whereas Redis is developed on C++, and it's not going to be a preferred choice for ASP.NET developers. You need to have same stack within the environment, and this is our experience that developers are more comfortable with the technology stack that they're working with. So our .NET developer has a preferred platform of .NET caching in regards to a C++ or a Linux environment. On the .NET Core, again, you would like to have something which is built natively available for .NET Core. So Windows support of Redis is not that great. It's a third-party, buggy, unstable version to start off, and there is no official support of it. They have official support of Linux, and even for their Windows deployments, where their client applications are on Windows, they actually have a Linux server which is using Redis. So this is a big turn-off for .NET developers. Then we have .NET and .NET Core clients officially available, and they don't have a .NET and .NET Core client officially supported. They have a third-party support for that matter. Clustering wise, we already discussed NCache is 100% peer-to-peer architecture, no single point of failure, no master or slave concept, no lead host as we had in App Fabric. So their cluster is not high available in true sense, whereas NCache is 100% peer-to-peer architecture. Configurations are dynamically applied on NCache, whereas you have to manually apply those on each server. So it's limited from that end as well. Split brain happens, you have to manually intervene for Redis, where NCache has a detection and recovery and automatic recovery out of that as well. And then we have a lot more features on the server side where we have cluster health events and some stability features. Our partitioning is completely dynamic in comparison to Redis, whereas Redis has a non-dynamic shards. You cannot readjust shards at runtime as we explained for NCache. NCache simply readjusts shards if a server goes down or a new server gets added. And our replication does not demand that you should, they don't have high availability if they don't have slave nodes. So replication and slave nodes are must for their high availability and replication. Whereas our case, we can have all servers, peer-to-peer architecture, and they also have the backups seamlessly created, and any server goes down, those active partitions are automatically readjusted, and then the backups are automatically readjusted, and cluster heals itself automatically. So that's another difference between NCache and Redis. And from feature standpoint, Redis does not have these features where we synchronize cache with database, with non-relational data sources, key-based dependency, server-side code, read-through, write-through, cache, startup loader, and similarly MapReduce and those entry processor, those advanced features that NCache exhibits. So this concludes our presentation. I would just reiterate real quick. Please let me know if there are any questions. So we extensively covered ASP.NET Core and caching requirements, and primarily we discussed all these use cases. We started off with ASP.NET Core specific caching, then we talked about data caching, messaging requirements, and then we spent some time on architecture and comparison with other options. I hope you liked it. I would hand it over to Nick. Please let me know if there are any questions at this point.
Okay. Is it possible to use NCache view state caching in an ASP.NET Core application?
Well, view state is obsolete now. It's a legacy technology, and it was specific to ASP.NET Web Forms, right? So ASP.NET Core, I've not encountered Web Forms in ASP.NET Core as yet. ASP.NET Core is all about MVC, so that's the new trend, new technology. It's newer version. Since MVC does not have view state, so you won't be able to use ASP.NET view state in ASP.NET Core MVC web apps, and also for ASP.NET web apps. But if you do have web forms anywhere in your environment, you can use view state caching out of NCache. So NCache view state caching works only with web forms because web forms exhibit view state, not MVC.
Okay, thank you. And guys, if you have any more questions, kindly type them in. You can always send us questions via email by emailing us at support@alachisoft.com. For any sales-related questions, you can reach us at sales@alachisoft.com. And if we don't have anything else, I appreciate your time. Thank you very much for joining us today. Thank you very much, Ron, for a wonderful presentation. And we hope to see you next time. Take care.
Thank you.